Hello and welcome to Grokking Graph Analytics. Let's go ahead and start with a motivating example. What we've got here is a historic map of the city of Königsberg that was in Prussia. I now believe it is in Kaliningrad, Russia. Let's point out a few things from it. What we've got is a river that separates the left and right land masses, and there's two islands. So we've got a island here, an island here, and then we've got a big fat landmass here, and a big fat landmass here. And connecting all of these land masses is a bridge, another bridge, and so on until we have a total of 7 bridges in Königsberg. And what the problem asks is, can you walk across all 7 bridges exactly once? And what Euler proved was that it is not possible. And he basically invented graph theory to mathematically prove that. Let's go ahead and redraw this bridge so that you have a cleaner image to reference. And we've got this landmass to the north and to the south. And then we can really ignore the water, right? We just redraw the bridges. So we've got this guy connecting this twice, and that another time. We have one going straight across, and a connection there. So that's really the essential history of graph theory. And graphs are really exciting because they help codify data more similarly to how we think about data. For example, if I was to ask you about your friend, you wouldn't really tell me their height and age and weight. You'd be more interested in their relationship with you and their relationship with the rest of your friend group or your coworkers or the rest of the world in general. And graphs really help codify relationships. And there's 2 relationships that graphs codify really well compared to other databases. Graphs help codify relationships, and 2 of the more interesting relationships that graph analytics can help us codify is the directional relationship, where someone might, or where one entity may be related to another, but the other entity isn't related in that same way. For example, if Alice knows Bob and Bob doesn't know Alice, that's a directional relationship. This might occur, for example, if Alice knows Bob, Charlie knows Bob, and Diane knows Bob, but Bob doesn't know any of them. An example of this could be the celebrity problem, where everyone in a given set knows one particular person in that set, but that particular person doesn't know everyone else. Graphs also help codify transitive relationships, where A may be directly related to B, but it's not directly related to C, but B is related to C, and so A is transitively related to C. An example of this could be a marketing campaign. In this marketing campaign, for example, a company may show Alice an ad for shoes, and Alice may tweet it. And then Bob follows Alice, and so he sees the ad and thinks it's funny or interesting and retweets it. And then Charlie follows Bob, right? And Charlie sees the ad and actually buys the product. And so in a classic analytics, using classic analytics tools, we've only spent money showing Alice the ad, but Alice didn't buy the shoes. And so this was a failed marketing campaign. But using graph analytics, we can show that because we spent money showing Alice an ad, Charlie ended up buying the shoes. And so using graph analytics, we can show that, oh, this is in fact a successful campaign. So I think discussing a brief history of databases helps frame why graph databases and graph analytics is particularly exciting, particularly now. Computers were originally hierarchical in their data storage, and that was, when they were first commercialized and put out there. And then it was in about the 1970s that relational databases were described, but they didn't really take off until the 80s. That's when they were first commercialized. And similarly, NoSQL databases were described in similar terms around when the internet took off, when we really started thinking about things in sort of an object relational kind of thing. And that's when NoSQL databases were described, and they really started seeing commercialization around the early 2000s. And so what we're kind of seeing is like this 20-year gap between different commercializations, right? We go from RDBMS, and then another 20 years, we have NoSQL. And if you've ever read Kevin Kelly's book, What Technology Wants, you can kind of see that we go from, commercialized hierarchical databases in the 60s, and we sort of go to a new commercialized paradigm every 20 years. So we've got 60s to 80s, 80s to 2000s, and now we're coming in the 2020s. And it's almost like we need a new paradigm because it's about time. And this is why I think graph analytics and graph data structures are particularly exciting right now. So we've covered a historical motivating example of graph theory and the basic developments around it, as well as why graphs are a interesting and important way to codify data. We also reviewed a brief timeline of databases, and that was mostly to sort of show that now is almost an appropriate time for graph databases to come into maturity. And we also defined graph analytics, which I hope is getting you excited and ready for future sections. So the next section is going to develop a common language around graphs and graph analytics. We're going to talk about things like nodes and edges and different ways to represent graphs. This will help build a common language and base for all of us around graph theory so that we can keep developing some really exciting algorithms. So stick around, and hopefully you'll see some really cool stuff real soon.